Sometimes we need to communicate with devices that are on a different network. In this analogy, Talithia wants to ask Rick to go to lunch. However, Rick is in a different room. She gives this message to Alan, who is adjacent to both rooms, so he can relay the message to Rick. IP addresses allow devices to communicate with each other that are on the same or different networks. Routers are used to forward messages between IP networks. In this analogy, each room would be a different IP network, and Alan would be the router. IPv4 addresses are 32-bit addresses represented in dotted decimal notation. IPv6 addresses are 128-bit addresses represented by colon-separated hexadecimal notation. The difference between decimal, hexadecimal, and binary is that the decimal number system is base 10, having 10 digits, 0 through 9. The hexadecimal number system is base 16, having 16 digits, 0 through 9, plus A, B, C, D, E, and F, which equate to decimal base 10, 10 through 15, respectively. The binary number system is base 2, having only 2 digits, 0 and 1. IPv4 addresses are 4 decimal numbers separated by a decimal, with each representing 8 bits for a total of 32 bits. IPv4 addresses have a 32-bit subnet mask also represented in dotted decimal notation. Subnet masks are a contiguous string of ones, with the rest of the mask being all 0 bits. This means that there are specific values that a subnet mask will have, such as 255.255.255.0. Subnet masks can be represented in slash notation using a slash followed by the number of 1 bits in the subnet mask. This is also known as the prefix length. Although the binary number system is beyond the scope of this video, the dotted decimal subnet mask of 255.255.255.0 would be the same as a /24 prefix length. An IP address has 2 parts, a network portion and a host portion. The 32-bit subnet mask is used to differentiate these 2 parts. The ones in the subnet mask indicate the network portion of the address, whereas the zeros in the subnet mask indicate the host portion. In our example, the 3 decimal 255s, 24 1-bits, indicate the network portion of the IPv4 address, and the decimal 0, all 0 bits, indicate the host portion. Let's look at an example. We have 2 IPv4 networks, 192.168.1.0 with the 255.255.255.0 mask, and 172.16.0.0 with the 255.255.0.0 mask. Network addresses have all 0 bits in the host portion. Notice that all the devices in both networks share the same subnet mask, which means the network portion of their addresses are identical, indicated in blue. Their host portions are unique, indicated in red. PCA has the IPv4 host address 192.168.1.100. If PCA moves to a different network, its IPv4 address will change and it will share the same subnet mask along with the same network portion of its address with all other devices on that network. As you can see, PCA now has the IPv4 address 172.16.3.0 with the subnet mask 255.255.0.0. which means it's part of the 172.16.0.0 network.